One container's memory leak grew from 256 MB to 1.2 GB, and because no memory limit was set, it crashed every other service on the node. Here's exactly why. Welcome to TheCodeForge. Before we dig into that production issue, let's cover containerization vs virtualization. Virtual machines use a hypervisor to emulate complete hardware stacks, each running its own kernel. Containers share the host kernel and use namespaces and Cgroups for isolation. This single difference cascades into every trade-off. Containers share the host kernel, which makes them fast and dense, but a memory leak in one container can exhaust kernel memory and crash all containers on the host. VMs prevent this entirely. Run two different containers and check their kernel versions. Both will show the host kernel, proving they share it. Virtualization abstracts hardware. Containerization abstracts the OS. VMs have separate kernels, so a kernel CVE in one VM doesn't affect others. Containers share the host kernel, so a kernel bug affects all containers. Inspect a container's namespaces and Cgroup limits. Each namespace isolates a different resource, and Cgroups enforce memory and CPU limits. Performance differences are context-dependent. Containers deliver near-native CPU and memory, but disk I/O in VMs can be 30–50% slower with emulated drivers. Always use Virtio drivers in VMs. Run Sysbench to compare CPU performance. Containers are within 2% of bare metal, while VMs add 5–15% overhead. Security isolation is the most important trade-off. VMs provide kernel-level isolation. Containers rely on defense in depth. For multi-tenant untrusted code, use gVisor, Kata, or Firecracker. Check a container's seccomp profile, capabilities, and AppArmor status. The default seccomp profile blocks dangerous syscalls. Containers scale in seconds and are 1050x denser than VMs. Patching is a single image rebuild. Debugging is harder in containers, so use sidecar containers with debugging tools. Scale containers in seconds and check their memory usage. Containers use megabytes, while VMs consume gigabytes just for the OS. The choice isn't binary. gVisor intercepts syscalls in user space, Kata runs each container in a lightweight VM, and Firecracker provides micro VMs for serverless. Each trades some density for stronger isolation. Install gVisor and configure Docker to use it as a runtime. Containers run with a user space kernel, adding a security layer. Containers save money through density and automation, but orchestration complexity is a hidden cost. Factor in platform engineering headcount when comparing. Calculate costs for 20 microservices on VMs versus containers. Containers often save 20–80% on infrastructure alone. Containerization shifts security left into the build pipeline. A vulnerable base image can compromise even the best runtime isolation. Scan images in CI before they reach a registry. This GitHub Actions workflow builds an image and scans it with Trivy. If critical CVEs are found, the pipeline fails and the image never reaches the registry. Container orchestration adds complexity. If your team can't handle a 2-hour VM outage, don't add Kubernetes. Start simple and only migrate when you need bin packing or rolling updates. A Nomad job definition is simpler than a Kubernetes deployment. It avoids the control plane tax and is suitable for smaller teams. This is the same issue we highlighted at the start. Here's exactly why that happened. A single container had no memory limit. Its memory leak grew to 1.2 GB, exhausting host memory. The kernel OOM-killer then killed pods from unrelated services that had higher OOM score values. The fix was to set memory limits on every container. With a limit, the Cgroup kills the leaking container before it can exhaust host memory. Resource quotas and alerts prevent recurrence. This is the exact mistake from the incident. Without a memory limit, a container can consume all host memory and trigger OOM kills on unrelated pods. Always set both requests and limits. Running containers as root is a security risk. If compromised, the attacker has root access on the host. Always use a non-root user in your Docker file. emulated disk drivers can degrade I/O performance by 30–50%. Always use Virtualization or NVMe pass-through for production VMs. The article's examples assume Cgroup v1/sys/fs/cgroup/memory/docker/. Modern Linux distributions, e.g., Ubuntu 22.04+, Fedora 31+, Debian 11 default to Cgroup v2, where the memory controller is at /sys/fs/cgroup/path/memory, current and memory max. Docker 20.1+ automatically adapts, but manual inspection paths differ. Check your host with statfc%t sys/fs/cgroup/. Cgroup to fs indicates v2. The article mentions setting memory limits, but doesn't show how to verify enforcement. Use Docker inspect to confirm the limit is applied, then stress test inside the container to observe OOM behavior. This snippet demonstrates verifying and testing a 256 MB memory limit. The article's cost analysis shows containers are cheaper, but omits scenarios where VMs are mandatory. Workloads requiring GPU pass-through, ML training, real-time kernels, low-latency trading, or specific kernel modules, e.g., ZFS, WireGuard. Containers share the host kernel and cannot load custom modules. Also, compliance frameworks like PCI DSS often require hypervisor-level isolation for multi-tenant environments. The article describes OOM-killer behavior but doesn't mention OOM-storage. By default, containers inherit the host's OOM score. Use OOM-storage or Kubernetes OOM-storage to prioritize critical containers. Set a negative value, e.g., -500, for essential services to reduce their kill probability, and positive values for batch jobs. This prevents the kernel from killing your API server before a background worker. To diagnose memory issues, inspect container limits, monitor host slab memory, and use Docker stats. Set up alerts to catch leaks before they cause outages. Let's run through some common interview questions. What is the fundamental difference between containers and VMs? VMs virtualize hardware with separate kernels. Containers virtualize the OS sharing the host kernel. How does a memory leak in a container affect other containers? It can exhaust host kernel memory, causing OOM kills on unrelated containers. What are gVisor, Kata containers, and Firecracker? Hybrid approaches. gVisor user space kernel, Kata lightweight VM per container, Firecracker micro VM for serverless. And a few frequently asked questions. When should I use VMs instead of containers? When you need strong isolation for multi-tenant untrusted code, compliance, or legacy OS requirements. Can containers be as secure as VMs? Not at the kernel level, but with seccomp, AppArmor, and non-root users, they are secure for single-tenant workloads. What is the biggest hidden cost of containers? Orchestration complexity, especially Kubernetes, which requires dedicated platform engineers. To recap, VMs provide strong isolation at a cost, containers offer density and speed but share the kernel. Always set resource limits and choose hybrid approaches when you need both isolation and efficiency. Ready to go deeper? Up next, Docker versus virtual machine, then how Docker works internally, then Docker architecture explained. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.